All right, we are on page 4 of GLA3 quadratic equations. We are completing the square. So question 12, by completing the square, the expression x squared plus 12x plus 110 equals x plus a quantity squared plus b, where a equals what and b equals what? Okay, so I know a lot of students think this is really a weird way to ask a question. What you need to do is just take the given trinomial, complete the square, and then you'll know what should go in place of the A and what should go in place of the B, ideally. That's what we're going for here. So I'm going to take x squared plus 12x plus 110, but I'm going to write the plus 110 kind of off to the side because I know I'm going to need to add something here. And also whatever I add there, I'm going to have to subtract it as well to just keep everything from, not being what it used to be. You got to keep everything equivalent. So I'm going to be adding something to complete the square. Okay. And whatever I add, I'm also going to have to subtract to zero it back out. And then I'm going to have that plus 110 on the end. Okay. Now, remember that perfect square trinomial pattern we talked about in previous videos. You have a perfect square on the front. You should have a perfect square as your third term, but we don't know what that would be. But we're going to add a perfect square here. So what perfect square should we add to complete this square, to make this a perfect square trinomial? So remember, the middle term is always a duplicate. It's always two terms that are twins combined. So if you divide this by 2, you'll see what that would have been. If I divide 12 by 2, I get 6. So that means that the square root of that last term should be 6. So then I need to add a 36 on each side. Or not each side, but I mean, I need to add a 36. And if I had an equal sign, I would also add 36 to the other side of the equal sign. But this is an expression right here. I mean, there's an equal sign here, but that's just showing us what our final form would look like. This is what we are completing the square of. And so without an equal sign to add 36 on both sides, I can still add 36 as long as I also subtract 36 to zero it back out. Okay, so the reason I did that is because I want to be able to take these three terms and rewrite them as a perfect square, I want to take this perfect square trinomial that I've created and rewrite it as a binomial squared, like that. Then I'm going to combine these two constants. So what is 110 minus 36? Let me just, 110 minus 36 is 74. Okay, so 74. So I'm going to have plus 74, right? So now notice when I look at, I don't know why this is all grayed out. There we go. When I look at this up here, it's x plus something in a quantity squared. The a was unknown. We were looking for it. That's what we wanted to put here. Okay. So this is in that position. So the answer for A is going to be 6. And then for B, it's this guy right here. And the 74 is in that position. So that would be our B. Okay. That's it. Now I'll put that, what is it? 6 and what? 74. Okay, number 13. Again, same idea. By completing the square, what should a and b be if you get it to this form? So I'm just going to take the trinomial, complete the square, and figure out what the a and b are supposed to be. So now I'm going to do it here. X squared, and get another color ink. And maybe even a new page as well. All right, so we have x squared plus 6x plus 142, but I'm going to rewrite that 142 down here out of the way so that I can add something and also subtract that thing in order to make a perfect square trinomial right here. So if I divide 6 by 2, I get 3. So 3 squared, which is 9, is what I want to add. I want to add 9, and I also want to subtract 9. Then I can rewrite the trinomial, the perfect square trinomial that I just created. I can rewrite that as x plus 3 quantity squared. Then I need to combine these two. If I subtract 9, that would be 133, I believe. So then this is my A, and this is my B. So 3 and 133. Okay. Question 14. It says find the last term to make the trinomial into a perfect square. All right. Now we'll find what we need to add to complete the square. And then when this is factored, what does it become? A binomial squared, right? So we're doing the same kind of idea, except we don't have an extra constant to move out of the way. And we're not trying to keep things equivalent anymore because we're not rewriting a whole thing. We're just being asked how we would actually complete this particular trinomial to make it into a perfect square trinomial. So it's very simple. We just need to decide what needs to be here in order for this to be a perfect square. Now, all we got to do, like we've done in the past, is figure out what this half of that middle term is, and we have 3 halves. So what we want to add on is 3 halves quantity squared. Okay, now that might seem scary to you, especially since we're probably not going to leave it as 3 halves squared. Let's see what happens if I put 3 half quantity squared. Ooh, ooh, 3 halves quantity squared. I wonder if it'll actually take it. Ooh, it didn't mind it actually. Remember when fractions, anything that's squared is just times itself, and when we multiply fractions, we just multiply straight across. So that would have been 9/4 is the simplified way to write that. I mean, it accepted what in the other way, but 9/4 is another way you could have answered it too. And then when this is factored, it becomes, so now we're going to take that perfect square trinomial and rewrite it as a binomial quantity squared. So this whole thing is equal, another way of writing it is to say x plus 3 halves quantity squared. That's it. Next, number 15. Find the last term, or the C, to make the trinomial into a perfect square. Same idea as the last problem. Again, we want to divide that middle coefficient by 2. And we're when we divide by 2, it's another way of cutting in half or taking it 1/2 of a time. So instead of dividing 14/5 divided by 2, we can just do 14/5 times 1/2 and multiply straight across. So we get 14/10, which reduces. And you might have noticed that it was going to reduce because here 2 goes into 14 7 times. So then I would have had 7/5. Okay. Or you could realize that 14 and 10 have a common factor because you can write 14 as 7 times 2, and you can write 10 as 5 times 2, and then these cancel to 1, right? So what we want to add here is 7/5 squared, which would be 49/25. That would complete the square. Then in factored form, it would be x. Always look at the sign in front of your middle term, x plus, and then the square root version of that fraction, which is 7/5. And go outside of the parentheses and put on an exponent of 2. And there you have your binomial squared to make a perfect square trinomial. Number 16, solve by completing the square and list the solutions separated by commas. Okay, again, we're completing the square, but we're solving. So rather than just completing the square, we're going to also find the x values that would make this statement true. So first step is to complete the square. The reason we want to do that is because then, once the square has been completed, and we have rewritten the trinomial as a binomial squared, then we can use the square root property, take the square root of both sides to solve for x. Okay, so we're going to start by completing the square. So we take the 5x squared minus 10x, and we're going to add 400 to both sides of the equation. Whenever you have an actual equal sign, you can go ahead and do that. Go ahead and move it over there. And so now where the 400 used to be, we are going to complete the square by adding half of 10 squared. So half of 10 is 5. So I'm going to be adding 5 squared. Use a different color for this step. I'm going to add 5 squared, and I've got 400 on the right side of the equal sign where I have to also add 5 squared, and I'm just going to add it as 25. 5 squared is 25. Now my trinomial on the left is a perfect, hold on, Lord, I almost messed this up. Remember, in order to have a perfect square trinomial, you do have to have perfect square on the front and perfect square on the back. Well, the perfect square on the front thing isn't working here because I have the x squared part, but I have a 5 there, kind of messing things up because 5 is not a perfect square. However, we can fix this. All we got to do, and we can do this because this whole thing is set equal to 0. So that is going to work out in our favor. You'll see why in just a moment. So I'm going back to the beginning. Okay, I have 5x squared minus 10x minus 400 equals 0. And since I do want to complete the square, but I don't have a perfect square lead coefficient, I'm going to start by dividing everything by that coefficient because it looks like everything is divisible by 5. And when I simplify, then I have x squared minus 2x minus 80 equals 0. Oh, it's beautiful, right? Isn't that beautiful? Now, I'm still going to complete the square. I still need to move the 80 out of the way because that's not a perfect square. So I'm going to scooch it over to the right side of the equal sign. X squared minus 2x, and I'm going to add and subtract, or not add and subtract. Remember before I was adding and subtracting because I didn't have an equal sign to work across, but in this case I'll be able to just add the same thing to both sides. So again, we go and we look at the middle term, we divide by 2, we see that 2 divided by 2 is 1, so I'm going to be adding 1 squared to both sides, and since 1 squared is just 1, I'll write it as 1 over there. Then this trinomial on the left can be rewritten as a binomial squared. X minus, always look at the sign in front of your middle term, x minus 1 quantity squared is equal to 80 plus 1 is 81. Okay, now we have completed the square. We have rewritten our perfect square trinomial as a binomial squared. We are all set up now to use the square root property, which we covered in a previous video. So now let's go ahead and take the square root of both sides so that we can get rid of this power of 2 there. And not forgetting to put a plus minus on the side opposite the variable. Okay, then now we have on the left x minus 1, and on the right we have plus minus 9. To get x alone on the left, we're just going to have to add 1 to both sides. And so we end up with x equals 1 plus or minus 9. Okay, so what do you do with that? You separate it into 2. X can equal 1 plus 9, or x can equal 1 minus 9, and both of those would make the equation true. So I have x equals 10, or x equals negative 8. 10 and negative 8. 10 and negative 8. 10 and negative 8, or negative 8 and 10. What'd I do? I messed something up. I typed something wrong, I think. Oh, goodness. I don't know what I did. It looks like I freaked. Oh, no, I just, it's okay. Everything's okay. I found it. There we go. All right. Hey, what's going on here? I just want a regular negative 8. Enter. Or submit question. There we go. Okay, now before I close this and go on to the next video for the next page, I just want to point out that when you're using the quadratic formula, when you get to that, you're going to see if you can take a little time to connect it back to completing the square and using the square root method, you might start to really understand why this all makes sense. But we'll talk about that in a future video.